Hello, welcome to our quick little intro to standard deviation and mean absolute deviation. This is from lesson 5.06, a little bit of additional content that we didn't cover in class, but the mean absolute deviation is something expected to be known how to do on the EOC. So we wanted to make sure that you guys covered it, and we'll make sure we address it again in a small group or warm up or something in class as well. So really quick, standard deviation is something that some of you might have heard of before. If you take a statistics course in your future, this is going to be the one that you probably will work with more frequently than the mean absolute deviation, which is what we're going to spend time on today. But I just want to quick show you what standard deviation is, so you're familiar with it because it does appear in our next lesson, just the idea of it. You don't have to learn how to compute it. But standard deviation, which is S, is a measure of spread that indicates how far the values in the data set are spread out from its mean. The greater the measure, the greater the data are spread out. And we'll talk about this tomorrow, but we use standard deviation when we have symmetric distribution or our, I can't remember the name of it, when we have like a box. I just call it all symmetrical. So it could also look something like this, where there's not as much variation from side to side. But basically, the skinnier your histogram looks, the smaller the standard deviation, so the less variation there is in data values. The data is closer together. Whereas if you have a large standard deviation in a symmetric data set, it's going to be more spread out. So that bell curve is going to be wider, flatter, more towards the axis. Okay, so that's just a quick intro to standard deviation. Now, the mean absolute deviation, this is what we're going to spend a little bit of time on today. It's the average distance of all the elements in a data set from the mean of the same data set. So basically, we're going to figure out how far each point is in the data set away from the mean, and then we're going to find the average of all of those distances. Now, on the EOC, this is from your EOC formula sheet. Notice under statistics formulas, this is the mean, X bar. We've talked about that a little bit. You find it by adding all your numbers together and dividing by n. You have your interquartile range. So if you need that, they remind you that Q3 minus Q1 is going to give you that. And then here, this is what we're going to focus on right now, is this mean absolute deviation. And I know this looks kind of scary from the formula, but I'll show you how to use it and what it all means in a second. So in this first example, find the mean deviation, and then I have a data set of 3, 6, 6, 7, 8, 11, 15, and 16. Now, what this means, so here, this is a Greek sigma, and that just stands for the sum. So this is saying the sum of all values n starting at the first data set, okay? So we're starting at the first piece of data in our set, and we're going all the way to the end. Okay, and the first thing we want to do in this situation, before we apply the formula completely, is we want to find the mean of the data. So if I find the mean of this data, I can type it all in and divide it by the amount of items we have. So I'm doing that right now, and I get 72 for my sum. And we have 1, 2, 3, 4, 5, 6, 7, 8 items. And 72 divided by 8 gives us 9. Okay, so there's our mean. Okay, so that's what I'm going to use right here, this X bar, when I'm finding my mean absolute deviation. Now the second step is to find the absolute value. Okay, this X sub I, this is just saying starting at your first data set, you're going to take the first data point and subtract it from the mean for each value, and you're going to go all the way up to however many values you have. That's what that n means on top of that sigma there, or the sum of all. Okay, so the third step, once we find each distance or each absolute value, we're going to find the mean of all of those values. So let me show you how to do this. It's not as difficult as the equation looks. The equation's much scarier since we're not familiar with that notation quite as much. So we're going to take the x sub I, that's going to be our value. So I'm going to take absolute value of 3 minus my mean, and my mean was 9. Okay, now if you remember, absolute value is just the distance away from 0, and they're always a positive value because distance is in positive units. So 3 minus 9 would give us -6, but as the absolute value, that's a positive 6 because it's 6 units away from 0. So I'm going to keep going. So 6 minus 9, okay, that's going to be 3. 6 minus 9, that's going to be 3. Absolute value of 7 minus 9, it's going to give me 2. Absolute value of 8 minus 9 is going to give me 1. Absolute value of 11 minus 9 is going to give me 2. 15 minus 9 is going to give me 6. And then 16 minus 9 is going to give me 7. Okay, so I found the difference, the absolute value difference of each piece of data. So this is my first piece of data up to my 8th piece of data. And now that third step says we're going to find the mean of all of those values. And really quick, before we do that, I would just want to show you what this chart would look like. So here's the mean. The mean is 9. And we're figuring out how far each data point is away from the mean. So all of these numbers are all of these numbers. Okay, that's what it would look like if you were to graph it. Okay, so for step 3 right here, I'm going to take all of these answers that I got. So 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7. And we're going to divide it by however many items we had. Remember, we had 8 items, so divide it by 8. So I'm going to plug that in my calculator. Okay, and I get 30 in my numerator. And then 30 divided by 8, I end up with 3.75. Okay, so that is my mean absolute deviation. So this tells me, on average, each one of these data points is approximately on average, is 3.75 units away from the mean. Okay? So that's what that data is showing me, using the mean absolute deviation. So really quick, I'm going to show you an example where we would apply. So in this example, it says consider the quiz scores of 2 students. So we have student R and student S. The mean score of student R is 8, and the mean score of student S is also 8. So that doesn't really tell us that one student is doing better than the other necessarily, but we could use the mean absolute deviation to determine which student was more consistent. Okay, so the mean does not provide us with which student was the most consistent, but if we use our mean absolute deviation, we can determine which one was more consistent. So if I start with student R, okay, we take our value, so the absolute value of that first data point, which was 3, and I subtract it from my mean. Okay, so I'm applying that first, here's my formula. Oops. That should all be over in. Okay, so the sum of all my absolute values, the differences of those 2 items, and then divided by the total number of items. So this is going to equal 5. Then I have 6 minus 8. That's going to equal 2. 8 minus 8 is 0. 8 minus 8 is 0. 9 minus 8, 1. 10 minus 8 is 2, and then I've got one more over here. I've got 12 minus 8 is going to give me 4. Okay, so then we're going to take all of those values and we're going to add them together. So 5 plus 2 plus 0 plus 0 plus 1 plus 2 plus 4, and we're going to divide that by how many items we had. We had 1, 2, 3, 4, 5, 6, 7 test items. So when I add those together, I end up with 2 for my mean absolute deviation for student R. Okay, so now I'm going to do the same thing with student S. Okay, so 1 minus 8 is going to give me 7. 1 minus 8 is going to give me 7. 3 minus 8 is going to give me 5. 7 minus 8, 1. Absolute value 14 minus 8 is going to give me 6. 15 minus 8 is going to give me 7, and I've got one more of those. So I'm going to add all those up. 7 plus 7 plus 5 plus 1 plus 6 plus 7 plus 7. I'm going to go ahead and add all those up. Okay, and that's all going to be divided by 7 because there were 7 test items. And that gives me 40. And 40 divided by 7 gives me 5.7. Okay, so what this tells me is that student R, on average, each point is 2 grades or percentage points. This is more at a point. So 2 points away from the mean of 8. Okay, so there's not a ton of variation. It's smaller. Where for student S, I get 5.7. So student S has a much larger variation in the data. On average, each point is 5.7 units away from the mean. So student R is more consistent because student R's mean absolute deviation is smaller. So student R is more consistent because of that. Okay, so that's one way that we could use that mean absolute deviation, excuse me, to determine which student is more consistent. So that's a great application. All right, so that sums up that little lesson, and we will probably talk about this 1 or 2 more times heading into the EOC as well. We'll see you in the next recording.